Chapter 7, Section 2 is on the powers of 10 and scientific notation. And we're going to start by looking at the table on page 466 because I'm not drawing this for you. Scientific notation is one of those sections that everybody has to do, and they do it once a year and then they forget how to do it, and they always ask, why do we need to know how to do this? Well, this makes a lot more sense once you understand negative exponents, because scientific notation really delves into the very large and the very small, and they're actually really useful in science. So 1 is the same as 10 to the 0. 10 to the 1 is 10, and they get bigger. Smaller than 10 to the 0 is 10 to the negative 1, which is 0.1, and 10 to the negative 2 is 0.01, and 10 to the negative 3, and you're seeing that you have 3 zeros on the bottom with a 1 on the top. You're also seeing that there are 3 decimal places. There are not 3 zeros before the decimal place. There are 3 decimal places. There are 2 decimal places. 1 decimal place. So make sure you have that understanding. So now as we look at moving decimal places, if we're going to go and do 10 to the 4th, what I need you to notice is not just that it's a 1 with 4 zeros like we talked about last section, it's that we're actually moving the decimal place over 4 times. And then 10 to the negative 4, we're moving the decimal place that used to be the imaginary decimal place after the number 1, we're moving that over 4 times. So there are 4 decimal places, not 4 zeros in front of the decimal place, but 4 total decimal places. And these numbers are called standard form, because they're going to ask you put this in standard form question for your homework. So I need you to understand that standard form just means regular numbers. So we're going to try a few before we move on. 10 to the negative 3, we're going to start with a 1, and we're going to make sure, and I'm going to start with a 1 over here, and we're going to move the decimal place over 3 times. 1, 2, 3. And I'm going to put my decimal place here, and I'm going to make it an obvious decimal place because I've got a lot of dots here now. So this is 0.001. And if you want credit for the right answer, please make sure that there is 1 decimal point answer. If I have 10 to the 2, I'm going to have 2 zeros. And if I have 10 to the 0, that's going to be 1. Check it out on page 467 at the very top, number 1. Pause here and come back when you're done. Check it out, number 1A, 10 to the negative 2 has 2 decimal places, which is 0.01. 10 to the 5 has 5 zeros, and 10 to the 10 has 10 zeros. And it's really helpful when you get some of these larger numbers to count from your imaginary decimal point. Every 3 gets a comma, so that you can actually see hundreds, thousands, millions, billions. This is 10 billion. Hundreds, thousands. This is 100,000. Okay? Can we do this backwards? When we're given a number with a lot of zeros, can we count how many spots that we have to move the decimal to change to get it to just 1? So let's try this. I've got hundreds, thousands, millions. I've got 10 million here, and I want to get the decimal point right there. I'm going to move that decimal point 1, 2, 3, 4, 5, 6, 7 times. So this is 10 to the 7th. Because I'm going to move it 10 to the 1 is 10. 10 to the 2, 3, 4, 5, 6, 7. If I move this decimal place 7 times, I'm going to get 10 to the 7th. You can also count zeros, but that doesn't help us here. Now, here, I'm going to move that decimal place from 2 here. I'm going to move it 1, 2, 3 to get to here. So if I start with a 10, I want to move that decimal place 3 times backwards. So 10 to the negative 3 is going to give me a small number like 0.001. 10 is 10 to the 1, and 1 is 10 to the 0. Try this yourself on Check It Out number 2 on page 467. Pause here and come back when you're done. Check It Out number 2, hundreds, thousands, millions. This is 100 million, and there are 8 zeros. We're going to move that decimal point 8 spots to get to that 1 point. So this is 10 to the 8. Here, 1, 2, 3, 4. I've moved it 4 spots, and I've made that number smaller. So this small number is 10 to the negative 4, and this small number, I've only moved that decimal point 1 place. So this is 10 to the negative 1. You can do this with any number. Let's say we start with 125, and I want to multiply this by 10 to the 5. Well, our decimal point right now is here. It's an imaginary decimal point that we need to add, because that's where we're moving 5. And we're moving 5 to make it bigger, because 10 to the 5 is a large number, not a decimal number. It's a large number. So we're going to say 125 with 5 zeros. And then we count 1, 2, 3, 1, 2, 3. So it's 12,500,000. Here I've already got a decimal point, and I'm going to make this number smaller by moving the decimal 3 places in the smaller direction. 1, 2, 3, which means this is going to be 0.0362. This number I'm making larger. I'm going to move this decimal point over in the larger direction 6 times. So I'm going to have 97, 86, 1, 2. I have 4 more zeros I need to add because I've already moved it 2 places. And then I'm going to count 1, 2, 3, 1, 2, 3. This one, I'm going to move 4 places in the smaller direction. So I have 195. I've moved it 2 already. I need to move it 2 more to make 4. That is my small number. Try this on Check It Out number 3 on the bottom of page 467. Pause here, come back when you're done. 853.4 times a larger number becomes 85,340,000, and 0.163 times an even smaller number, I'm going to move that decimal point 2 more out, so it's 0.00163. Please make sure to ask if you have any questions. Then we come to scientific notation, and scientific notation always has 2 parts. It starts with a number that's greater than 1 and less than 10. So there's always a digit that's not 0 and a decimal place, or maybe just a digit, but it's never 2 digits before the decimal place. So it's between 1 and 10, and it has a power of 10. And it could have a negative power of 10, and it can have a bunch of different numbers after here, but that first digit and decimal is really important. If you're getting things into scientific notation, that means there are 2 steps. First, you're going to move the decimal to the spot just after the first digit, and then you're going to adjust the power of 10 to show what you moved. So we're going to give that a try. First, we have 327 million. Now, for scientific notation, I want my decimal to be right there. So I moved it 3, 6, 7, 8 spots. So this is going to be 3.27 times 10. Now this is a small number, and I want to make a big number, so I'm going to multiply it by 10 to the 8th. Here I'm going to take the digits, 6, and I want my decimal there, 5, 2, 9. I want my decimal there. How many times did I move that? 1, 2, 3, 4, 5, 6, 7. I moved that 7, but this is a bigger number than this, so I have to make this smaller. Times 10 to the negative 7. Next, we have an astronomy word problem, and in that word problem, they give us 4 different numbers, 2 of them in standard form and 2 of them in scientific notation. And the first questions here ask us to figure out 2 of them, and then the Check It Out asks us to figure out the other 2. figure out the other two. So I'm going to work all four of them for you. This is 1.43. So I want my decimal there, and it's going to be times 10, and this is small. I have to make it bigger like this, and we moved it 5 times. Similarly, 7.784 times 3, 6, 7, 8, 10 to the 8th. Now for these two, we have scientific notation. I'm going to move this decimal place 8 spots. So I'm going to have 5, 9, 1. I just moved it 2. I have 6 left. 1, 2, 3, 4, 5, 6. And I want my happy commas. 591 million. Here I have 1.3. I'm going to take that decimal. I've already moved it once. I have to move it 3 more to get to my 4. Okay? If you have any questions about this, please let me know. The last thing this section asks you to do is to be able to compare and order numbers. So because you didn't have any other scientific notation practice, I'm going to ask you to do these. 2.87 times 10 to the negative 5 and 3.6 times 10 to the negative 2. Because we practiced positives, I'd like you to practice negatives. Push pause here, do these 2 problems, then come back when you're done. I'm going to put my 287 here, and I'm going to move this decimal to make this number smaller, because this is a small number. Make it smaller by 5 decimal places. I've already moved it once. I have 4 left. 1, 2, 3, 4, and then my decimal place. I'm going to put 36 here. My decimal was here. I've moved it 1 to get it here, and I'm going to move it 1 more to get to 2. So 0.036. Please ask if you have any questions. The last thing this is going to ask you to do is be able to compare and order numbers in scientific notation. So we're going to start by looking at the power of 10 if all the numbers are in scientific notation. If they're not all in scientific notation, it's really difficult to compare them. But so far the ones that I've seen all start with a digit and a decimal, or just a digit. So you're comparing apples and apples. That's good. You're going to look at all the powers of 10, and you're going to pick the smallest one, which is going to have the smallest exponent of 10, and work your way up. And some of them are going to have the same exponent, so then you're going to have to compare the digits if the power of 10 is the same. Okay? Let's look at an example. Here I've got a whole bunch of scientific notation numbers. We're going to start with the smallest one, and that's going to be this one. So here is our first number. 9.9 times 10 to the negative 4 is the first one. The second one, look, I've got 2 to the negative 1. So now I'm going to compare 1.2 and 1. Which one's smaller? 1 is smaller. So I'm going to do 1 times 10 to the negative 1, and then 1.2 times 10 to the negative 1. So these are done. Then I have a 4, so my 8.2 times 10 to the 4th, and that one's done. And then these have the same power. So what's smaller, 6 or 2? So I'm going to go 2.4 times 10 to the 5th and 6.2 times 10 to the 5th. And that's how you put scientific notation in order from least to greatest. You have one more list to try, number 5. Check it out on the bottom of page 468. Pause here, try that, come back when you're done. So here I've put them in order, and then I mixed myself up. 0.004 is actually smaller than 0.0052, so this is 1, 2, 3, 4, 5, 6. Okay? So it's easy to get yourself confused. Please be careful. Your homework for this section is page 469, numbers 14 through 46 even. Okay, I will see you tomorrow.